Okay, so here's the shortcut or the practical formula for the population variance. You see here, all what you need is just sigma x square and sigma x all square. Okay, to apply that, let's consider this example again. And I have here 6 values. I need to calculate sigma x and sigma x square. So to get sigma x, okay, all I have to do is just add these numbers. 3 plus 8 plus 4 plus 7 plus 0 plus 2. So let's get a calculator for that. 3 plus 8 plus 4 plus 7 plus 0, of course, plus 2. So the answer is 24. So let's write 24. Okay, now that's sigma x. In fact, here I need sigma x all square. So the next step is maybe to get sigma x all square. So all what I have to do is to square this value. 24 square is equal to simply 24 multiplied by 12, 576. 576. Okay, so we got sigma x all squared. Now we want to get sigma x squared. Sigma x squared is different. I need to square every value first. This should be 3 squared, this should be 8 squared, this should be 4 squared, and so on. So I need to calculate 9 plus 64 plus 16 plus 49, and then of course 0 square, and then 4. So all I did here is I squared every value, before I add them. Okay, so 3 squared is 9, 8 squared is 64, and so on. And now let's, after squaring every value, now let us add them. So 9 plus 64 plus 16 plus 49 plus 4, that's equal to 142. Okay, 142. Okay, you could have done this with a calculator from the beginning. So for example, you could have said, okay, this is my data, right? 3, 8, 4, 7, and 0. Okay, so the 3 square could just say 3 square plus 8 square plus 4 square plus 7 square plus 0 square, of course, is 0, and then 2 square. So that will, when you click equal, then again will give you 142. So that's, some people just use a calculator for that, and some people like to have a table for that as well. So instead of doing this, they can just use a table. So they put the x's here, and they put the x square here, and then they get the sum at the end. So they write the values here: 3, 8, 4, 7, and then 0, and then 2, and then square each value. This would be 9, 64, 16, 49, 0, and 4. Anyway, that's just a different style, how you want to do it, it's up to you. But at the end, I want sigma x here, I want sigma x square here. So when you get, you add all of these after squaring them, then you'll get 142. And of course, the sigma x we did is 24. But remember, we don't want the sigma x here. We want sigma x all square, which is this one. So anyway, let's apply the formula now. We are ready. This is 142 minus sigma x all square, which is 576. I have to divide this by n, which is the data size. 1, 2, 3, 4, 5, 6, 6 values, right? And then divide again the result over 6. Okay, so I need to get this fraction first and then subtract it from 142. Okay, so 142 minus this, I need to take this table away. So that's here equal to 142 minus 96 divided by 6. And then if you subtract this, That's again 46 over 6, right? Which is again the same value we got before. That's approximately 7.6. 6. We can say 6.7 approximately. It's 6.6667, but I don't have a space here, so I'll just say approximately 7.7. Okay, so that's how we do it without calculating the mean in the beginning. So this is a practical formula. It seems a bit larger, but it will come actually in the exam formula sheet. You just need to learn how to calculate sigma x and then square it and then calculate sigma x squared. So remember, this is different from this one. This is not the same. And then once you know how to calculate each one and you know that they are different, you plug them in here in the formula, and then hopefully you don't make a mistake in the calculation. So that's how we get the population variance.